Hello everyone, so welcome to 6.7. We haven't been really doing a lot of equation work and equality work, but that's finally what this section is all about, solving radical equations and inequalities. So we've got some steps. We want to try to isolate the radical on one side of the equation. We're going to raise each side of the equation to a power equal to the index. So if I had a square root, I'm going to square both sides to eliminate the radical. And then I'm going to solve the resulting polynomial equation, checking my results. Checking your results is going to be pretty crucial just because we are working with square roots and we don't want our radicals to have something that is negative underneath if we have an even index. So let's take a look at this first one. I've got the square root of y minus 2 minus 1 equals 5. So first thing I'm going to do is to isolate that radical. So I'm going to add 1 to both sides. Now I've got the radical on one side. I'm currently doing a square root common to index. So I'm going to square both sides. I have y minus 2 equals 36. Now I'll add 2. Y equals 38. Now I do want to check it. So if I plug it in, I've got 38 minus 2 minus 1 equals 5. 38 minus 2 is 36. And square root of 36, we want the positive root. There's no reason to think otherwise because there's no negative out there or anything. So we've got 6 minus 1 equals 5, and that is indeed true. So y equals 38 is our answer. Let's take a look at this next one. So I can't really isolate my radical due to the fact that there are two radicals. If you do have two radicals in your equation, it is best for them to be on opposite sides, and you'll see why in a moment. So we are going to square both sides. We've got a common square root, so we have an index of 2. So I've got x minus 12 equals, and I do need to FOIL this. Remember, to FOIL a binomial, anything with a plus or minus sign in the middle, if it helps, write it out. So I've got 4 minus, when I multiply I'll get negative 2 root x, and then another negative 2 root x, so negative 4 root x, and then I'll end up with a positive x. Negative times a negative is a positive, and then square root of x times square root of x is x. Now I'm going to isolate my radical again, moving everything I possibly can over to my other side. So my x's cancel out. Now, to get rid of that negative 4, we're going to divide. And square. So I've got 16 equals x. Now I do want to check my answer, so I'm going to plug it in. So I've got 16 minus 12. 16 minus 12 is 4. Square root of 4 is 2. Square root of 16 is 4. 2 minus 4 is negative 2. That is not a true statement. So I have no solution. It's cases like this that we do need to make sure that we are checking our answers, because sometimes they will work and other times they may not. A lot of times when you have the radical on both sides, you have to be particularly careful. Let's look at one where we're not looking at a square root. In this case we have a cubed root, or it's raised to the 1/3 power. So same idea. I want to isolate my radical. If you wish to rewrite that as a radical, that is fine. So since that is to the cubed root, I'm going to cube both sides to undo my cube root. I will subtract over my 1 and divide by 3. So I got y equals negative 42. Let's plug it in and check. So I've got 3 times negative 42, which is negative 126, plus 1. I want the cubed root of that, plus 5 to equal 0. Negative 126 plus 1 is negative 125. The cubed root of negative 125 is negative 5. Negative 5 times negative 5 times negative 5 is negative 125. And negative 5 plus 5 is indeed 0. So y equals negative 42 is a solution. So paired with equations, we have inequalities. We do want to make sure that if we have an even index, that we make sure that our radicand is not negative. And we'll kind of talk about that below a little bit. So once we make sure that our radicand's not going to be negative, we're going to solve our inequality algebraically, making sure that if we divide by a negative, we flip our sign, follow every other rule that we would typically, and then we're going to test our values to check our solution. So, if you have a single radical and it's greater than or equal to a positive number, once you've already simplified, so your radicals alone and we're greater than or equal to a positive number, you don't really have to worry about checking for cases to make sure that your radicand is greater than a number, because you're already going to be greater than that number. You're already going to be greater than 0. On the other hand, if you have a single radical less than or equal to a positive number, you do have a finite set of solutions. You do have to watch out for the case where, well, we don't want to go too far less than whatever number we're working with because we don't want our radical to be less than 0. And of course, if you are less than or equal to a negative number, then it's not going to work out. If you're less than 0, also not going to work out, but you can be equal to 0. So sometimes you can save yourself some work if you recognize, oh, my radical's less than negative 3. That's not possible. End of problem. So we do have a case here where we are less than or equal to a positive number. I want to make sure that I take care of my case to make sure my radical is greater than or equal to 0 first. So I've got 3x minus 6 is greater than or equal to 0. This 4 doesn't mean anything for me in this case. I'm just worried about that radicand. So we're going to add 6 and divide by 3. This x is greater than or equal to 2 is going to be part of my solution. Now let's solve the rest of it as if it was totally normal. So we're going to subtract 4, square both sides, add our 6, and divide by 3. So our solution set should be x being greater than or equal to 2 and x being less than or equal to 5. Now to check for inequalities, you're technically supposed to check all the possibilities. So we can make a sign chart. Fill in our circles because we are or equal to. And we're looking to test values. We know that we want to be between these two values, so this should pass. The other two should fail. We just want to test numbers that are, in this case, less than 2, between 2 and 5, and greater than 5 to make sure that when we plug into that original that we do indeed meet our mark. So let's plug in any number that we want that's less than 2, maybe 0. So I'm plugging it in. 0 times 3 is 0. 0 minus 6 plus 4 less than or equal to 7. Well, we're not dealing with imaginary numbers in this case, so that definitely fails because that's not a solution set. Let's test a number that's bigger than 5. Let's plug in 6. So I've got 18 minus 6 plus 4 less than or equal to 7. And I am likely going to get decimals here, so you would be using your calculator. So I've got the square root of 12 plus 4 less than or equal to 7. I can simplify that square root of 12 if I wanted to, though chances are I am just going to be plugging it into my calculator anyway. And when I type that in, I end up getting 7.46 less than or equal to 7. That is indeed false. So all we got to do is check that indeed values between 2 and 5 do work out. So maybe let's plug in 4. So I'm going to plug in 4. Now I've got 12 minus 6 plus 4 less than or equal to 7. Square root of 6 plus 4 less than or equal to 7. If I add these up in my calculator, I get 6.45 is less than or equal to 7. That is indeed true. So my final answer for this one, 2 less than or equal to x less than or equal to 5. Just as we got from both setting the radicand greater than or equal to 0 and solving regularly. Now let's take a look at this one where we have a greater than or equal to. I don't have to worry about any cases where my radicand would get me a square root of a negative number because I'm already going to be greater than or equal to 5, or actually technically greater than or equal to 4 if I subtracted my 1. So I don't have to worry about that extra case. I'm just going to have one inequality part as my answer. So just solve like normal. Square both sides. And I get x is greater than or equal to 7. Now I do want to make sure that that is indeed true, so I can plug in any number I want that's bigger than 7. Let's say we plug in 10. So I have the square root of 10 times 2 is 20. 20 plus 2 is 22. Plus 1, I want to make sure that that's greater than or equal to 5. Square root of 22 plus 1 is 5.69. And that is certainly greater than or equal to 5. So my answer of x is greater than or equal to 7 stands. That's all I wanted to look at with you, so thanks for watching, and I'll see you in class.